Welcome to the Conservation Applications Training. I'm Jeff Hyatt, Civil Engineering Technician. I work out of the State Office in Champaign. This presentation will introduce you to Illinois NRCS's most popular conservation practice, the grassed waterway. This may not be apparent to you because in your county or district group, you may put in a lot of wascobs or terraces. However, statewide, the grassed waterway is the #1 conservation practice planned and installed. This is because Illinois is generally flat. This topography creates watersheds that are too big for wascobs. Most of my experience has been in central Illinois where we can't see the top of our watershed from the outlet. Grassed waterways are my favorite practice, along with block chutes at the end of the grassed waterway, then outletting into a drainage ditch. But we will talk in depth about block chutes and other grade stabilization structures in a later training. After the introduction, we will be discussing the planning for a grassed waterway with a producer. As we work our way through this presentation, we will learn the definition, purpose, and engineering application of grassed waterways. We will introduce common terms used for grassed waterway design and construction. Then we will go over the preliminary process of planning for a grassed waterway with a producer. What is a grassed waterway? Grassed waterways are natural or constructed channels shaped to required dimensions and lined with suitable vegetation for stable conveyance of runoff. Albeit in my 20+ years of working with grassed waterways, I have never seen a natural channel that I have said, yep, that's a grassed waterway. Seed it down, we are good. All of the channels I have completed an inventory and evaluation process on for a possible grassed waterway have needed engineering and construction to be a stable conveyance for runoff. This is a picture of an established grassed waterway functioning. Your eagle eye may already spot a problem that is developing for this grassed waterway. Along the right side in the distance, there is runoff flowing down the outside of the grassed waterway. This is a common issue. We will talk about this type of problem later in the presentation. Stay tuned. We use grassed waterways to accomplish a few different purposes. One purpose is to safely convey runoff from terraces and diversions and other concentrations of water. Other concentrations of flow could include road ditches, culverts, and ephemeral gullies, which we often see in fields. But note, with ephemeral gullies, in addition to conveying runoff from an ephemeral gully, we would want to treat the ephemeral gully itself, and this can be done with the grassed waterway. In addition, grassed waterways can be used to protect or improve water quality. There are different types of gully erosion. There are rills, mega-rills, ephemeral gullies, and classic gullies. Rills are little narrow gullies that are not very deep gullies. You can cross rills with farm equipment. Mega-rills are rills that are deeper and wider, but can still be crossed. When you see a stockpile of soil and there are a bunch of little gullies coming down the pile, you are looking at rills. Ephemeral gullies are usually wide and shallow gullies that can be crossed easily with farm equipment. When crossing them, you may feel the whoop-dee as you go over them, but they usually aren't a concern for losing a front tire of the tractor. One wouldn't make a special pass to work them in. An ephemeral gully can be tilled, then planted. However, by the next year, they will appear again. Classic gullies are the ones that everybody thinks of when you mention gullies. Deep, wide, ugly cuts in the ground. They cannot be crossed with farm equipment, and to be able to cross them, they will usually have to be worked in, usually with heavy equipment. A grassed waterway is usually a sound alternative if you have ephemeral or classic gully erosion in the field to be treated. For rills, another alternative may be better. What was or would become a gully is now a grassed waterway. The shape of the waterway controls the velocity of the water flowing down the waterway. The vegetation retains the soil, and all this works to prevent erosion from concentrated flows. What a grassed waterway is not in the next slide. As I mentioned earlier, grassed waterways are not used to control rill erosion. If there is rill erosion occurring, start from sheet erosion, choose another alternative to control the erosion. If the grassed waterway is capturing sediment, the sheet and rill erosion isn't being controlled in the upland above the grassed waterway. Sediment captured in a grassed waterway will lead to a shortened life for the grassed waterway because it will silt in and not be able to handle the design capacity or the amount of runoff it is supposed to. We want to work with the landowner to keep the sediment or soil up in the field, but we want the soil that is being transported by the runoff, the sediment that does make it to the waterway, to keep going. When planning a grassed waterway, there are many parameters that need to be met. For example, a grassed waterway can be used when additional capacity is needed so the concentrated flow does not continue to erode. For the second bullet, a grassed waterway is needed when vegetation must be established to stop the erosion. There are some instances where this is not the case. If the velocity of the channel of the concentrated flow is not erosive, then the area can be a surface drain without grass. This occurs in very flat country. Lastly, we must have a location that's favorable to growing vegetation. If the construction of the grass waterway will expose subsoil that is not conducive to getting grass to grow, examples would be low fertility, droughty soils such as sand and sodic soils. We would need then to look at another conservation practice. Some people would say that all that is needed is to add fertilizer to get grass to grow. But some subsoils will need a lot of fertilizer applications to get the grass to establish, let alone to flourish. Here is a prime example of a gully that needs a grassed waterway. This is probably the most common site you will run across when a producer says he has a problem in the field. He has been able to work the area and still farm through the erosion for a few years, and now he realizes he needs help with it. Here is an established grassed waterway that needs to be rebuilt. This waterway has existed long past its practice life of 10 years. The field has terraces and residue management implemented, but the waterway still needs a rebuild. There are multiple issues with this waterway, including siltation, which causes the grassed waterway to have no capacity. No capacity causes runoff to flow down the sides of the grassed waterway. This out-of-channel flow creates gullies as it washes unprotected soil away. What flow is still in the grassed waterway is now causing a head cut to form in the silt filling the channel. A head cut, for those that don't know, is the start of a gully. This grassed waterway has been rebuilt, and an aluminum toe wall was installed as the stable outlet for the grassed waterway. Here is a great example of a grassed waterway that is silted in, causing the runoff to flow down the outside of the grassed waterway. Can you identify another problem with this site? For those who said a tile problem, you are right. The field soil surface is dry, but there is still tile flow draining the grassed waterway and probably the upland. The tile has developed a break or a hole, and now the water that was flowing in the tile has come to the surface and is running on top of the ground. This is a close-up of a grassed waterway that has silted in. As you can see, the flow runs down the side and has created a new channel. This waterway is around 12 years old, so it has exceeded its life expectancy. The producer has always planted edgerows along the edge, which compounds the erosion in the channel. Something to remember when you run into this situation is you must ensure you have enough spoil out of the proposed channel to fill this erosion and have positive drainage into the rebuilt channel. Another option is to investigate moving the proposed center line to this channel and then shaping the old grassed waterway to be farmed. The following slides, we will be discussing each of these terms. Two parameters we use in Illinois to design a grassed waterway are capacity and stability. Capacity is the amount of volume of runoff a waterway is designed to handle. Our standard requires us to design for a minimum peak runoff for a 10-year, 24-hour storm. Stability is the size of the grassed waterway required to prevent erosion of the channel. This is defined as the velocity of the flow in the channel. Maximum design velocity depends on the soils where the grassed waterway is being built. Of the four factors that influence stability and capacity, the top three, depth and width, grade, and vegetation, are things we can change while designing a grassed waterway. We design for depth and width, grade, and vegetation of the grassed waterway so that the waterway can safely transport concentrated flow that would previously have been causing a gully. Capacity and stability consider the volume and velocity of the runoff. In addition to runoff, waterways carry silt from the field. A certain amount of silt will accumulate in a waterway. However, that siltation has been built into the design process, calculations, models, and of the software. In our work, we not only want to prevent erosion in the gully, we also want to keep the soil where it is in the field. The conservation planner should be working with the producer to provide upland treatment to hold soil in place where it is and reduce the sedimentation of the grassed waterway. In order to design a stable grassed waterway, the speed or velocity of the runoff flowing in the grassed waterway has to be fast enough to prevent siltation, but slow enough not to cause erosion in the channel of the grassed waterway. These speed limits are 1.5 feet per second and 4.0 feet per second, typically. In Illinois, we have what we call standard design grassed waterways. Waterways designed to a standard width and depth. Standard design grassed waterways are for small drainage areas. If a site meets the criteria to use a standard design, there is no requirement to meet a minimum velocity. We will cover more on standard design grassed waterways later in the training. More information can be found in the Illinois supplement to the Engineering Field Handbook, Chapter 7. The term crossability means how easy it is for the farmer to drive through the grassed waterway with farm equipment. As designers, we want the farmer to be able to drive through the grassed waterway without risk of damaging the grassed waterway, his equipment, or himself. This is provided by a general side slope for entry and exit of the grassed waterway. These are just minimum crossability parameters. Flatter side slopes are even better. For the parabolic grassed waterway crossability determination, one would divide the top width by the depth. An example is a 40-foot wide by 1.6 feet deep grassed waterway. We take 40 divided by 1.6, which equals 25. Since this is greater than 24, it is determined to be crossable. Drainage is a term you will hear throughout the training. For this slide, drainage refers to the tile or subsurface drain, as ILNRCS calls it, to drain the grassed waterway. The purpose is to keep the grassed waterway dry enough to get the grass to grow well, not to be used to drain the field adjacent to the grassed waterway. The caveat to the purpose of only draining the grassed waterway is when there is existing tile installed that is connected to field drainage tile. We will take that tile into consideration for design purposes. More on that in a later presentation. In areas where the soils do not allow effective drainage from tile, a stone center drain can be used to dry out the grassed waterway. Stone is placed in the center line of the channel to provide a path for excess water to flow. Not many of these stone center drains are used in Illinois. I just wanted to show another alternative to subsurface drains. Sometimes erosion can occur and gullies can form in the waterway before grass is established. Rock and fabric checks work to minimize erosion during the establishment. Rock checks are strips of rock installed perpendicular to the flow of water in the grassed waterway. These use RR3 sized rock, which is big enough so the flow doesn't dislodge the rock usually. Fabric checks are strips of geotextile that is installed perpendicular to the flow of water in the grassed waterway. The fabric has specifications. A person just cannot use several pairs of old blue jeans and call it a fabric check. Both checks are used to slow gully action up the grassed waterway before the seeding is established. They are an interruption in the soil that the gully won't overcome, hopefully. If the gully is severe enough between the checks, maintenance or even reshaping will be required. Fabric checks work as well as rock checks in most grassed waterways and are generally preferred. In some cases, rock checks are better than fabric checks due to the velocity of the runoff along with the erodibility and fertility of the soil in the center line. When the grassed waterway needs to be reshaped, hopefully in 10 years or more, rock checks are harder to remove than the fabric, and the rock checks can be dragged by the farmer as they mow and as well damage the mower. Under no circumstances should rock checks be used to exceed the design velocity of the grassed waterway. Here you can see a plan view and the cross section of both a rock check and a fabric check. Rock on top and fabric check on the bottom. Spacing of the rock and fabric checks is determined by slope, and as you can see, they are placed closer together the steeper the grade. Every 100 feet for slopes under 1.5% and every 75 to 50 feet for steeper slopes. Here you see a fabric check doing its job. The flow is coming towards you in the photo. See how the gully has been stopped at the fabric check? Here is a great photo of a rock check slowing down a gully. As you can see, this grassed waterway has been seeded and mulched, but a late summer storm caused a significant runoff event that the newly built grassed waterway couldn't handle, and a gully formed between the rock checks. The photo also shows the problem of rock being moved and will have to be put back in place before reshaping and seeding of the grassed waterway. A grassed waterway must have a stable point at its lower end for the runoff to leave, otherwise the gully will return. We call this the outlet for the grassed waterway. Typical outlets for grassed waterways are grade stabilization structures, filter strips, and another grassed waterway. Sometimes a flat area in the field where there isn't an erosion problem and where we cannot maintain the grassed waterway can be used as an outlet. Flat areas where I have outletted grassed waterways include pastures, timber ground, even subdivision yards. The outlet must be able to handle the flow coming from the grassed waterway. If the outlet for the grassed waterway you are designing is a narrow road ditch, then it probably is not considered an adequate outlet, and the grassed waterway will be eroding in a few years. As the grassed waterway designer, you will have to prove the road ditch can handle the flow from the grassed waterway. Caution should be used when outletting onto filter strips. Filter strips aren't designed to handle concentrated flows and may not be able to maintain stability with the directed runoff from the grassed waterway. Vegetation is a key component of a grassed waterway and needs to be done well to have a successful grassed waterway. Conservation Practice Standard 342, Critical Area Planting, has the grassed waterway seeding criteria. This includes the proper permanent seeding, nurse crop with permanent seeding, and if necessary, the temporary seeding when grassed waterway construction is outside of the seeding dates for the permanent seeding. Now let's go through a scenario where a producer would like a grassed waterway. We want to make sure a grassed waterway is the right practice for us to install. We want to see if there are other alternatives that the landowner might not know about. A problem we have is the landowner hears about the Great Cost Share program. His neighbor received a very large chunk of the money for installing a grassed waterway with very little out-of-pocket expense for him, and then the government will pay him for 10 years to keep the grassed waterway. So our landowner wants to fix his erosion problem. We do a site visit and determine moss copse might be a better alternative than a grassed waterway. We should work with the landowner, present the alternatives, and let him decide. Many grassed waterways have been installed because of economics, when another practice would have even been better. Sometimes the landowner's expectations and timeline does not match what we can do. You need to determine the landowner's expectations and when they would like to have a completed project. Many times landowners and producers think all we do is seed the gully and there isn't much else done. Or they think they only need 20 feet or so wide waterway, and anything bigger is a waste of good farm ground. Talk about timelines. When do you expect to have a design for them and any financial assistance program cutoffs? It might be some time before they are able to construct a grassed waterway. Do they want to wait? I have had farmers come in after fall harvest and want something done since they broke a combine axle crossing a gully. Winter is not the time to be building a grassed waterway. Don't ask how I know. During this conversation, ask about tile and utilities. Be sure to tell them to mark existing tile so that you can locate it during the survey. On the Illinois NRCS engineering webpage, under Illinois Engineering Conservation Practice Guidance, you can find this pamphlet, A Landowner Guide to Constructing Conservation Practices, and it is downloadable. This is a useful document to share with the landowner or producer you are working with. It will give them an idea of what to expect as we work with them to install their conservation practices. Construction timing is always a concern. It is important to work with the landowner or producer to schedule the best time to build the grassed waterway. If there will be a delay in getting the grassed waterway built, what can the landowner do in the meantime, such as draw bale dams, taking the area out of production and sowing a temporary seeding? Will the landowner get the seeding completed and hopefully up quickly? Farming a field with a grassed waterway may be new to the landowner and producer. Many times they will want to make things look neat by placing end rows along the grassed waterway. This should be avoided. We should encourage the landowner to farm through or to cross the grassed waterway. This allows any runoff following the rows to enter the grassed waterway and not run down the sides of it. As a maintenance practice, the landowner should cut any ridge off the edge of the grassed waterway that would be a barrier to runoff getting into it. There are situations where inrows along a grassed waterway can't be helped, such as if the grassed waterway is adjacent to a property line or a non-cropped area. Then we can plan accordingly with such things as kickers or special operations and maintenance guidance. Kickers are farmable berms that can be placed perpendicular to the grassed waterway to direct any flow along the grassed waterway into the grassed waterway. The following are references for you when planning and designing the grassed waterway. You should know Section 4 of the Field Office Tech Guide, or FOTOG, is where all our conservation practice standards are located. Conservation Practice Standard 412, Grassed Waterway, is the standard used for this practice. It has all the criteria that is required for a grassed waterway to be designed to our specification. Number 2 is the National Engineering Field Handbook, or EFH, and number 3 is state-specific material inserted into the EFH. You can't just use one, both are valuable references. The Engineering Field Handbook, or EFH, is the technical reference for our engineering practices. The Illinois EFH supplements are additional information that is relevant to Illinois. The National Chapter 7 describes the grassed waterway design method of tractive stress. Illinois designs grassed waterways using the velocity design method. Illinois has a supplement to the EFH describing the velocity method of design and the justification for using the velocity method. Another example of state-specific information is the minimum standard waterway design. The minimum standard waterway design was developed in Illinois and is not used nationally. The basis of ILNRCS's design methods for grassed waterways is the Agricultural Research Service's Agricultural Handbook number 667. This September 1987 version describes the tractive stress method. As I stated earlier, Illinois ILNRCS still uses the velocity method, which was developed by the Soil Conservation Service and revised in 1954. To recap this presentation, we discussed the definition, purpose, application, and common terms of grassed waterways. We also discussed the process of planning with a producer to install a grassed waterway. As you advance through this training, we will get into the grassed waterway design and construction in more detail and depth.